All right, good afternoon, everybody, and welcome back to another live stream. So today is going to be another special kind of live stream. So we did one of these a couple months ago, where typically we do these live coding kinds of things. And over the last couple weeks, we've been working on our MLX Gradio application. But I thought it'd be fun to take a step back and talk about a more general topic this week. So with the MLX Gradio project, by the way, it's actually honestly a little bit that I just didn't have time to code on it this week. So we will get back to that maybe next week or the following week, but we're definitely going to get back to that, round that out. But what we're going to talk about today is just a primer to AI specifically for business leaders. And so let's set the scope of what I mean by that in particular. When I mean business leader, I don't necessarily mean somebody who is going to be leading AI for their organization. So, for example, if tomorrow we had another, if tomorrow, like one of my executives or my executive left today that is over my space, and then I had to train that new person on or talk to that new person about an AI strategy or whatever, that would be a totally different conversation than what we would be having today. What we're going to be talking today instead is thinking about how every single person that works in any sort of business can think about AI as a whole. And it kind of doesn't matter the environment that you work in. You could be a sole proprietor, you could run a mom and pop shop, or you could work in a major Fortune 500 company. The idea here is that we're going to give you a way to help you think about AI and how to perhaps adopt it within your own business practices. So let me just give a high level rundown of what you can expect so that we're going to be talking about today. Now, if you are unable to stick around, no worries. These sessions are recorded across all three platforms that I stream on. So if you are on LinkedIn, or if you were watching on YouTube, or if you were watching on X, no worries. It's recorded everywhere. And I will also be taking questions on LinkedIn and YouTube specifically if you have any. So the rundown, what are we going to be talking about today? So I'm going to introduce a little bit about my background because some of you may not know my full background. And then we'll move into the AI topic. So we'll talk about what is AI, or thinking about AI as a tool, or how does AI work? Now, we're not going to go super deep into how AI works, but I want to give it enough of a primer because it's going to help set the table for the next topic there, which is responsible AI and data policies and things like that. Then we'll move into talking about the different types of AI. So today, you all are probably familiar with generative AI and how popular GenAI is. So this stream today is going to look at AI as a whole. Now, we will have a specific section after talking about the different types of AI on generative AI in particular, just because I know that is really popular. And then finally, we'll wrap up with, talking about things that AI can't do or that AI is currently limited in today. All right. So let's move into talking about my background for a little bit. So you all may know me as the AI guy, which is kind of weird for me to think about. And it's weird for me to think about because historically speaking, I've worked far longer in non-technical roles than I have in the AI space. So namely, both my bachelor's degree and my master's degree are in business degrees. So my bachelor's is in business administration, my master's is in organizational leadership. When I began with my company 12 years ago, I stepped in. Well, I was actually an externally contracted associate at that time, but I stepped in as a project management consultant. So I did some project coordination kind of work or Scrum Master kind of work. And then eventually, when I did transition into an internal employee within State Farm there, I became a business architect. I guess that is one other thing I do want to mention here really quick is I love State Farm. They're an excellent employer. We're not going to talk about them today. And that's just, this is just not the right context to be talking about them. But again, and it's nothing that I love working for the company. This is just not the right context to be talking about State Farm. All right. So anyway, so back to my background. So as I've said, I've been working in these different business sort of spaces. And so I also have designations like my project management professional or my like a Six Sigma green belt, things like that. And so actually you all may know, so I do these live streams and I also do blogging, and you all may know me specifically for the blogging side, specifically to talk about AI, but that's not how my blog began. how my blog actually began when it was way back in 2016, way before I knew anything about AI. And so how the blog actually got incepted was I was coming out of my master's degree program at that time, and I had to do a lot of writing on leadership and stuff for that master's degree program, as you can expect. And I really enjoyed the writing, and I really enjoyed the dialogue that me and my colleagues had back and forth, my fellow students. And so, I started the blog then, and I specifically focused on the business topics, specifically project management sorts of things. And so I read a lot of business books and stuff. And to be clear, a lot of them were not worth my time. And it's unfortunate. Like, it was just one of those things where I had to learn the hard way. Like, I don't want to say that business books are bad per se. It's just that a lot of business books out there have the tendency to focus in on one idea and then just extrapolate it on it over and over and over with like anecdotes and stories and whatnot. And so basically what I'm saying is most business books you can compile down into a blog post or even shorter, maybe even a paragraph. There's not really many that are worth reading cover to cover. But one field that I did find very interesting in particular, and this is just for me, is this idea of persuasion psychology. So if you are not familiar with persuasion psychology, it's the idea of understanding how humans work, understanding the behavior that they exhibit, and that way you can, I don't want to say take advantage of them, but more so to help work your way through the business world and things like that to help navigate that. And so I think because, the temptation there is to think like, oh, persuasion psychology, so you're just trying to manipulate me, right? That's not at all the case. I mean, that can be the case, but that is not my goal particular. And I would say with persuasion psychology, there is a very ethical way to do it. And that is the way that I try to do it. So like I said, so actually two books that I can recommend that you could read cover to cover, both by the same author, Dr. Robert Cialdini. Cialdini spelled Cialdini, something like that. He has two books. So his first book came out, I think, in the 70s. It was called Influence. And then he had a follow-up book more recently, I think it was in 2016, called Persuasion. Both of those books talk about persuasion psychology and the different tactics that you can apply for persuasion psychology. Those books are excellent. So I just became so interested in this sort of cognition idea that you can even see. So I don't know if you notice down here, I'm going to try to point to it. I'm not going to point to it well. My logo down here in the left-hand corner. So I actually designed this logo right here that I'm pointing at. And so if you look at it closely, it was actually a kind of a happy accident because so if you're not aware, I do all my own like graphic design and stuff for all these blog posts and whatnot and whatever. And so I think I was just trying to create a generic like person icon whenever I was messing around in Affinity Designer, and I did this offset path thing that like I did it a couple times, and what it ended up looking like is this logo here, where it was like almost the way I kind of look at it, and maybe other people can disagree. You could disagree with me, and that's okay. Is it almost looks like the cross section of a brain from above? So like if you were to take a brain, like my brain, and you were to like cut my head off there, it almost looks like you're looking down. But what I really like about this logo is so I kept the person in the center, and I kept all the paths around, but I kind of made it look like a maze. Because if we're really honest with ourselves, we still don't really understand human cognitions to its full extent. And so it's kind of a maze to get to that center of who we are. And that's what really fascinates me. And so if you're wondering, well, why are you talking about human cognition and persuasion psychology and whatever, this segues nicely into artificial intelligence. So let's talk about what is artificial intelligence at a high level. Generally speaking, artificial intelligence is simply seeking mechanisms to artificially emulate human cognition. And so if you go and look at any of the top AI researchers out there today, so the Andre Karpathy's out there, the Jan LeCuns, they are deeply entrenched in trying to understand these sorts of things in human cognition, because we're trying to basically take the understanding of the brain and map it specifically to a machine. Now, it doesn't necessarily have to be a machine or a computer. It's just that's the way that AI is manifested. So this idea of artificial intelligence has been around since like the 1950s. So there was, I don't remember the details. I'm going to screw this up. There was a university out there, I believe, that put together this proposal that said, okay, we're going to get these smart folks together in a room for like 6 months or something, and we're going to solve AI within 6 months. Now, I don't think I need to tell you that obviously didn't pan out. Like it failed quite miserably, actually. And I'm not going to go into the full history of AI. If you want to read on the full history of artificial intelligence, I would recommend the book Artificial Intelligence by Nick Bostrom. Yeah, I think that's right. I'm getting confused with another author. But anyway, so if you want to learn about that history, you can go learn that history. But really, artificial intelligence has manifested in all these sorts of different ways. And we will talk more about these different ways further on down. But actually, one thing that I do want to recommend here, I'm going to start sharing my screen, so is this particular video. Because this video, as it indicates what is artificial intelligence in 5 minutes, it's excellent. And you can see it's got 1.8 million views. If you don't know this person, this is Dr. Raj Ramesh. So Dr. Raj Ramesh works with me at State Farm, and he's a personal friend of mine. Raj is a great guy. He's a super bright guy. And even though this video is now 6 years old, it is still very much relevant today. Now obviously it doesn't have some like the GenAI stuff in here, but I would still say go and watch this video, because this video is going to give you a very, very nice overview of artificial intelligence in 5 minutes. And you know, the views speak for themselves. So I love this video. It's great. In fact, I was commenting down here to Raj, like, I've referenced this video so many times. I referenced it 4 years ago. I referenced it 2 years ago, and I told him, yep, I'm referencing it again today. So it's a great video. And Dr. Raj, he's a great guy. Very, very nice person, very good person to meet and know. So anyway, so I would encourage you to look at that. But let's move, before we go more into the depth about what these different facets of AI are, let's talk about AI as a tool in general. All right, so I don't know if you all have noticed over here, I got some props today. So I got a couple props over here. So what I like to think about is every time some new advancement in AI comes out, it's like we get one of these new tools here. So just for a fun fact, like, I don't know if people know this, every once in a while, like twice a year, on Instagram in particular, I will do this stupid segment that I call Dave on the House. And it's me just doing like random like house projects, and I'll tell people like how to fix a toilet or whatever, because my dad he's very handy that way, and he's taught me a lot of these things, so it's actually been really helpful to know these sorts of things. But anyway, so I got my tools here. Like, this is my favorite tool here. This is the power drill. Most people are going to enjoy these sorts of things, but the idea that I'm trying to go with this here is that not all tools are created equally necessarily. So when I think about like the drill here, the drill is, this is, like I said, this is the one that I use the most often. But if I needed to paint a wall, well, I can't paint a wall with a drill. If I wanted to hammer a nail, well, I can't really hammer a nail with a drill. And so even though this is a really, really great and shiny tool, and I love to use it all the time, it's just not the time and place to use it for everything. Likewise, on the other hand, we have this tool over here. So if you don't know what these are vice grips. And what vice grips are really good for is, let's say you drill in a screw, and you can accidentally, if you're not careful, you could strip the screw. And what I mean by that is that, like, the top of the screw, if you like, especially a Phillips head screw, like the plus sign, like, if you are not careful, you can accidentally like shave away the metal edges to where it won't screw out anymore. And I'm speaking from experience. So the way that you can get those out is by using the vice grips here. So what you do is, like, you like let's say the top of my straw here was like the thing. Well, I don't want to do that on my straw. That's gross. Well, I think you get the idea. Like, let's say I want to do that here. So what I would do here is I would clamp it down and then like use the screw on the top, and that way, because then this would get really, really tight, and then I could manually kind of just screw out the screw that was stripped in there. And so the reason I bring that up is I don't use these that often, but when I do use them, they are absolutely imperative. And so that's what I want to talk about here, because I think the problem right now that we have with generative AI in particular is that people are looking at it like, okay, well, I got this shiny new drill. Now, can I go hit a wall with it? Can I go paint a wall with it? Can I don't know, all these different things. And so people are not. Basically, what I'm trying to say here is that you need to think about the business problem you're trying to solve, and not necessarily come along with a drill or a hammer and see the whole world as a nail, that sort of thing. Okay, so let me check out my notes here. All right. So anyway, so let's talk about how to think about AI holistically. Holistically speaking, the way that AI has manifested, I'm going to turn on my fan because I'm really hot. Hold on just a second. All right, there we go. Oh, I got hot in here. Okay, where was I at? Okay, the way that AI has manifested today in terms of the things that you might be familiar with, like ChatGPT or any of these other GenAI things, is that really it's looking for patterns in data or patterns in information. So I actually like to joke sometimes that we who work in the AI ML space are really just professional pattern finders. Is we're just looking for patterns in data and everything. And so that's really important for your business processes. And this is where you all as business leaders all out there are extremely important when it comes to working with folks like me for machine learning and whatnot. So, because I don't know your space. So I have this highlight. So I'm looking at my notes down here. This is the one line that I put in all caps. Domain knowledge is important. And I put that with a ton of exclamation points too. And let's really drive this home. So I'm going to share my screen here, and I'm going to give a very specific example. Okay. So this is the website Kaggle. For those of you who are not familiar with it, this is a data science competition website, but it also has other things like data sets and some courses out here. Actually, the free courses out here, they're actually pretty dang good. So I would recommend them. Although if you do want to explore that, you do need to know a little bit of the Python coding language first. So you may want to get a primer on that, and then come back. But anyway, so we're looking at the Titanic data set here. And so if you're not familiar with this data set, it's very much like it sounds. It is like, what's that movie? So the movie Titanic with Leonardo DiCaprio and Kate Winslet, we're talking about that right here. So what this data set here is, and let's go ahead and look at it, is it contains all these different variables within the data. And so a variable, you may hear this referred to as a data attribute or a feature. It's basically something, so like you have a bunch of records, or like imagine you have an Excel spreadsheet and you just have a bunch of different rows that represent each individual person, and then you have the columns in your Excel spreadsheet. That's what these variables would represent. And so what this toy data set here is designed to do is you are trying to predict based off of a person's features here, can you predict if they survived or not? And so when we look in the different variables here, so we have things like so this is the target variable that we're trying to predict for. Did they or did they not survive? So a 0 would be no, they did not survive. A 1 would be yes, or they did survive. And then you have the different variables down here of so this is the P class. This is actually the ticket class. So I don't remember what this is. So I know that there's like a first, second, and third class. I don't know if that was a first class was more expensive than a second class. I don't remember. And then you have some other ones that are a little bit more self-explanatory down here. And so the idea with machine learning in particular is that or AI in general, is that we are trying to look for the pattern amongst these different variables to try to predict this survival class. And so it's a little bit of a mystery game, and it's kind of fun to me. And like a year or so ago, we actually went through in a different live stream series how you might build a model around this particular data set. But what I want to come back to is the domain knowledge being important. And the reason that domain knowledge is important is because I don't know, actually, so I do know now, but at the start of this, which of these features do you think is the most important? So I'll tell you what it was here in a little bit. But like I just said, this P class, I don't know what this ticket class was. I don't have the domain knowledge around that. If I had the domain knowledge around that, then maybe I'd say, you know what? First class passengers, they always got on a lifeboat and they got out. I think this is the most predictive class. And that's where you all come in as business leaders. You all bring that business domain knowledge in to help us understand and look for these patterns in the data. So even within most companies that have machine learning engineers or data scientists, they are working with the business areas to tease out those different patterns that there might be, and then building some sort of AI model around that so that way we can predict the future. And we'll get a little bit more into that in a little bit. But so I will tell you here, after doing the modeling, it was actually the sex here, the gender of the person that was the most indicative. And we'll talk, and so even though this is most indicative, you may not want to use a variable like this, and we'll talk a little bit about more about that here in a little bit. All right. So let's talk about how an AI model is trained per se. So when an AI model is trained, it's basically, I'm going to show a little graphic here. This is a very, very, very simple graphic. So this is just so this is representing some data from the iris data set. So the iris data set is just a data set about different iris kinds of flowers. And I guess there's different kinds of, I don't know what you call them, like subspecies of these different irises. So you have like the setosa or the versicolor. And so basically and along with in this data set here, you have things like the sepal length or the stem length or different things like that. And again, I don't know anything about flowers. I personally don't. So I don't know which ones of those are most important. But let's say I did, and we got to the point where we were ready to build a predictive model. What happens with the predictive model here is, and you can kind of see with the blue line, so right now we're at the ending point. So it's about to, all right, so there was the starting point. Unfortunately, I can't pause this whenever I want. But you can see when it starts off, that it does a very poor job at delineating between the setosa and the versicolor here. You can see here as the model gets trained that this particular line here is shifting around, and you can see it kind of jitters a little bit there. Like it's not a smooth shift. And this is a very, 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 very simple example. In most machine learning, it's actually more complex. So what's going on here is that when a machine AI model is being trained, it is like, let's go back to the Titanic data set here. It's looking at every single record here that you may have, and to be clear, like these features of the data here, you can't use them in their raw state. You have to massage them, and that's we call that feature engineering. That's kind of beyond the scope of this. But anyway, so we are trying to, after we take these feature engineered variables, we're trying to predict this target class here. And this is so we would actually refer to this as a binary classifier, because we are trying to classify, and it's a binary thing. It's a yes or a no in this case, or I'm sorry. Well, I guess, or a lived or did not live, or so something like that. So as the machine learning algorithm or the AI algorithm is looking at each different record, it is taking this line here and saying, you know what, based off of what I'm seeing right now, we need to nudge this line a little bit more. And so what the math kind of looks like for this behind the scenes. So we're gonna get into a tiny, tiny bit of math. Nothing beyond what y'all did in 7th grade or 8th grade. I think I even maybe did this in 6th grade. So y'all may recall this formula here, the old slope formula. And this is again just a very simple example to help highlight what I'm trying to talk about here. So this is y equals mx plus b. So the x-axis is this horizontal axis, and this vertical axis would be the y-axis. So what we're trying to do here is for a given input value, so for a given x value, so let's say the value here is 2, what would be the y value that we would get back out? And so what the machine learning algorithm is doing is each time that it sees a new record, is it takes this slope value here and it changes it just a tiny, tiny bit. So that's why I put these sliders on here, so you can see as we start to change it around, then you can see this line starts to move some. And again, this is a very simple example. In reality, it's much more complex than this. It's actually not even possible to visualize, but I hope you get the idea that this is how the computer is actually doing its learning, if you will. And so the one thing I guess I want to highlight here as well, coming back to this visual, is you'll notice that because this is a very simple example, you'll notice that all of the setosas versus all the versicolors are very grouped together in a way that very cleanly delineates what we're expecting here. But in the real world, that's definitely not the case. Data is very messy and everything. So when we actually make a prediction using the machine learning model or the AI model, we are making an inference. And when I mean an inference, I mean we are basically making a very, very educated guess. And because it's an educated guess, there's actually there is no guarantee that the answer will be correct. And so And that's what I wanted to highlight here, is because the answer can't be guaranteed. These are the sorts of guardrails that you need to put up and kind of think about whenever you are trying to build out your own machine learning, or like trying to incorporate AI into your own processes. Okay, just checking the time. All right, so I'm going to go back to just me. So let me go back to my notes here. So now well, actually, I do want to keep. Oops, didn't mean to do that. I did want to keep this up here though. So now with this in mind, knowing that the data is very important and massaging the data is very important, and how messing with the data here can give you different results, let's talk about responsible AI and what responsible AI means. So there are a couple different attributes to responsible AI, and the first one I want to touch on, I guess there's one that I did not write down in here, but like it's a little bit of a given, and that's information security. When I mean information security, I mean that with any of your data, it doesn't even matter if it's AI or not, you want to be protective of that data. So you want to ensure that whatever data, like however your databases are set up or however your APIs are set up, you want to make sure those are all locked down and least privilege and yada yada yada, things like that. So that's a given. That's a given for anything. So that's why I'm not really going to touch on that here. But I do want to talk about responsible AI as a whole and how you can be thinking about responsible AI. So the first one, and I think this is probably the biggest one, is data governance. And when I mean data governance is how are you using the data responsibly? And when I mean using the data responsibly, I mean it's kind of a no-brainer, obviously, to not use things like credit card number or social security number. However, we also want to be careful about bias from even normal variables. So like what I mean specifically here, so like when we come back to the Titanic data set, I mentioned that the most predictive feature of this data here to actually to predict the survival of a person is gender. And that is not something like gender can introduce bias. And it's not just gender, it could be sexual orientation, religion, things like that. Responsible AI and data governance, you need to set those things up front that says, you know what, we are going to commit to not using these things, or we're going to commit to using them in a very careful capacity. So there may be most companies would actually look at a variable like this and a model like this and say, you know what, we don't want to use something like that because that could introduce unfair bias, which is not right, and from an ethical perspective and whatnot. And so from the responsible data AI perspective, we would want to avoid those completely. Okay. A couple other things that we want to talk about with responsible AI. So let's talk about interpretability as well. So interpretability, so with like a model like this, where something that is extremely simple, it's kind of easy to understand what the model is doing here, because we can see clearly by this blue line that, yeah, okay, so we understand that the reason that the model is making its predictions is because this blue line is such as it is. Unfortunately, this is not at all the case with these more complex models. So specifically like the chat GPT models and the generative AI models, the interpretability, because so coming back to this graph here, excuse me, I would consider this like one parameter of a model, like this y equals mx plus b. That would be one parameter. But if you think about like ChatGPT has 70 billion parameters, so it's got a lot more to deal with than just like something simple like this. And so when you're dealing with one parameter versus 70 billion parameters, well, when you get beyond like 1,000, you just can't interpret the thing anymore. I mean, like, so what I mean by that is that like you can look at the because at the end of the day, the way that these models are trained and the way that they're saved is just like this graph here is representing. We save out because we are messing with this value here in particular. We save these out, and we call these the model weights, or the AI model weights. And so it's just numbers, as you can see. Now I'm just using like a simple integers and float, like simple flow values, but it's usually like this number would be like, I don't know. Oops, that's not. I didn't mean to type characters there. I meant to type numbers. It's usually something like that, and like thousands of numbers like that. And so you and I, thousands of numbers like that doesn't mean anything to you and I. And so that's something that you'll want to take into consideration as well. Is how important is model interpretability to you. And so for things like generative AI and ChatGPT, it may not be as important. However, when you're thinking about actuarial science, or like, so actuarial science meaning like if you are trying to write insurance underwriting models, you want like if you're going to the Department of Insurance, they're going to want to know what that model's doing. So most companies, I think, do not actually use machine learning specifically for things like actuarial science. Instead, that they'll use more deterministic statistical models, which I think is appropriate. Like that is definitely appropriate, especially, machine learning. It's kind of, you're at the mercy of trying to figure out what this number here is, like the slider that I'm messing around with. At least with statistical modeling, you have much more control over that. But it's also a lot harder too, and that's why becoming an actuary is a very hard kind of job to do, because you need to have all that specialized knowledge there. So that is something to definitely be mindful of. Let's talk about model validation also. So the silly example that I always like to use is imagine that we had a time series model. So a time series model is just looking at here's what happened the last 6 months. Like, think about the stock market. Here's what happened the last 6 months. Can we predict what's going to happen in the next month? So let's say I created a time series model specifically for the sale in 2019 for the sale, predicting the sales of toilet paper. Well, that model at the start of COVID became crap because obviously the purchasing patterns for buying toilet paper at the time were just insane. I don't know if y'all remember that. Like, shoot, like I remember, like, it was like not a real stressor, but it was a little bit of a stressor. Like, are we gonna have toilet paper? Like, that's a like. But my point is that when these models, so I keep coming back to this picture. Let me share my screen again. Like, these models here, when you this is trained at a snapshot in time. Like this is like, you can set up a process that is constantly doing retraining, but there's a risk to that too, like that you may not want to do. But like because these are trained at a snapshot in time, so if you think about that example I was telling you with the toilet paper sales, well, that model just became null and void. So what you want to do is you want to have some sort of model validation, AI model validation practice in place where on a regular occurrence, it could be once every couple months. It could, if you're seriously concerned about it, it could be daily or weekly, where you are using specific metrics and stuff to ensure that your model is still giving the right results. And there are specific metrics and stuff. I'm not going to talk about those metrics because that kind of goes beyond the scope of what we're talking about here. Your data scientists or machine learning engineers, they'll know those metrics for you. And I guess that along those lines, I've kind of taken a little bit of a different approach, or like a thought pattern toward what they call citizen data science. So what citizen data science is we now have all these different tools that like AWS offers or whatever, where it's like very much plug and play, like these different AI models, and so, like, a lot of them can be good, but it's also kind of risky in the sense that, like, especially with like, because you might be surprised, like, so because obviously like ChatGPT is the hot thing right now, but this kind of model that I'm looking at right here, this predictive model, or so this is a binary classifier. There are the iris data set that we're looking at represented here. Even though there's only 2 classes represented here, the actual data set has 3. So we would call that a multi-class classifier. These models are where the money's at. Like, and I think obviously OpenAI is making like so much money off of like ChatGPT right now, and I think companies will get up to the point. But like in the last like decade or so, it's these kinds of models that are making the money. So like, do not write these off. And so that's again coming back to my whole prop thing over here. Like I said, you might not use your vice grips that much, but when you need them, they're extremely valuable. And so when generative AI came along, I think there was an implicit assumption that like, okay, this kind of superseded what it came for. No. This is just another tool in the toolbox. It's a really shiny tool. It's a really cool tool. And it's a tool that maybe I'll use all the time, like my drill over here, but it's just another tool in the toolbox. Yeah. So let's talk about well, actually, I guess there is another point in here. Another thing that you may want to consider when thinking about responsible AI is having a human-in-the-loop validation mechanism. And what I mean by that is, so let's say like you have like any of these predictive models that are predicting whatever, before it goes out into a real context to be used for a real thing. So like, let's say, like Wendy's, for example, they've been using like voice assistants or whatnot to like take orders from people in their drive-thrus recently. So a human in the loop mechanism would be like, okay, so still have the AI take the order and fulfill the order. However, before, or not fulfill the order, my apologies. Take the order, but before it gets fulfilled, have a human look at that and say, you know what? The AI got that right or the AI got that wrong. And that's just a helpful stopgap to make sure, because these models, again, they're not perfect. They do have a tendency to, because these are, predictive models and they are inference. We're gonna give a very educated guess. We're gonna try to get it right as much as we can, but we can never truly say 100% of the time it will always be correct. If you want that, that's what you would have to do statistical modeling, standard statistical modeling, and again, that's very effective, but that's not always a viable solution either. Like like for example, statistical modeling in and of itself can't emulate ChatGPT. Like it just can't. So all right, so that's responsible AI. So let's talk about the different types of AI. So we've been talking about these a little bit. So the one that we've talked about here the most often, just using this as an example. So this is what we would call this picture here, even the Titanic data set, where we are using data to try to predict a target variable. So in this case, we are trying to predict did the person survive or not. In this case over here with the iris data set with the flowers, we are trying to determine, is this a setosa subspecies or a versicolor subspecies. We refer to this as supervised learning. And when we mean supervised learning, I mean that when we are passing the model into when we are passing the data into these mathematical algorithms that end up representing these AI models, that we're giving it the correct answer at the time of training. That way, whenever we want to infer a new value in the future, then hopefully it will be like close to on point. So, and it doesn't have to necessarily be binary classifiers or multi-class classifiers. Like you could build a supervised learning model specifically for like predicting house costs. So like, housing costs, that's going to be a variable kind of thing. Like it's not always going to be like 100K or 200K. A house can be anywhere, a very specific dollar amount, like I don't know, $170,000 and 45 cents. I don't know, something very specific like that. And so you can do these sorts of things with that supervised machine learning kind of concept. So on the flip side of supervised machine learning, we have unsupervised machine learning. So where with supervised machine learning, we were trying to predict a certain value. Unsupervised machine learning is this idea of, well, we got this data here, and we know that there's like some goodness in here, but we're not really sure how to make sense of it. So a particular example that I can give here is when I was going through my Udacity class, I did a lot of my own studies through the Udacity platform with their nano degrees, and they had a nano degree at the time, and I think it's still around, called the data scientist nano degree. And so one of the final projects that you could select from was taking, they partnered with Starbucks to take anonymized data it was basically like the customer purchasing patterns. Like it was just a bunch of data they threw at you, and they basically said, okay, go make sense of it. Like go use unsupervised learning to see what insights you can draw out of it. So with that project in particular, what I was able to do was I was able to use an unsupervised machine learning algorithm to cluster the customers into 4 different customer types, and by classifying them that way, then we get a better insight onto what these groups are. So like, it's been several years since I've did this project, but I want to say like there was one group where it was like older folks who are like in their 40s to 50s. I guess they're not. Some people are like that. they're looking at me like, that's not old. It's like, okay, well, I'm 34, so they're not old. I didn't mean that way. So my apologies. But anyway, so what it was interesting was that those people were purchasing on average like 3 or 4 drinks. And you might be wondering, well, why is that the case? And then when you start to drill down further into that data, it's because those are people who have kids, and like not just like little kids, but I mean like teenagers or college age students. So those are people that are going to be purchasing for more than one person. And so by gleaning those insights, we can say, okay, based off of this person's purchasing patterns, how can we market to them better? How can we give them different coupons? Oh, that was another thing that they had in there. They had like different coupon codes and how people interacted with the coupons, or not just coupon codes, but like different like sales campaigns, like how people reacted to those. And so by using unsupervised machine learning, we can glean those insights to say, okay, we now that we understand this better, let's take business action to market to this segment better, and let's do this to market to this segment better. So that's the value of unsupervised learning in particular. And so both supervised and unsupervised learning generally work on what we refer to as tabular data. And what tabular data is, just imagine an Excel spreadsheet. So like I was saying, so let me show my screen once again. So like the Titanic data set. So like these variables here would represent the columns of the Excel spreadsheet. And then each individual record of each individual person would represent a row. So that is referred to as tabular data. And again, so tabular, like it is not glamorous per se, but let me assure you, this is where the money's at. You can make a lot of money in making some really good supervised or unsupervised tabular models. So let's move well, I guess there's another, I did write this down here as its own separate class, but it's really also kind of a supervised machine learning kind of aspect, and that's time series analysis. And I gave an example of time series analysis already. So like, let's say you are trying to predict the price of the stock market. And so you have stock data from like the last 6 months, and you want to predict like the next month. Or like I was saying with my silly toilet paper example earlier, let's say I'm a grocery store owner and I want to predict how should I be forecasting my costs, or I'm sorry, not my costs, my stock for what I should be keeping. So should I be like maybe last quarter, we had a ton of people that were really interested in milk, so maybe we should be stocking more milk. Or maybe people weren't as interested in batteries. I don't know. I'm just picking out random things. So by using that time series forecasting, we can help kind of do a prediction to say, okay, based off of this information that we're seeing, let's again take business action appropriately. And so all these examples that I'm trying to give you, you can kind of see the domain knowledge is extremely important. So even looking at like a time series analysis to forecast like stocking milk on a regular basis, why is that the case? And I can't answer that as a machine learning engineer. Now, again, this is a fake example, but that's where I would go and talk to the grocery store owner and say, okay, what are you noticing? And maybe it is, I don't know, the grocery store owner says, we've had a lot of people come in here with concerns about their vitamin D levels. I don't know. The silly example, but it's that sort of business domain knowledge that you all as business leaders have in your head that is extremely important. So that is where I'm trying to get you to think about these different things, because your domain knowledge along with my skills, it's very much a partnership. Like I can't come into your company today and tell you what you need to do with AI. All I can do is tell you how to think about it, or you can tell me how your company works, and then we can brainstorm together. But it's very much a partnership. So let's keep moving on then to the other types of AI. So let's talk about reinforcement learning. So this one's probably not one that most people use most often. Reinforcement learning, the most practical application I can think of it right now is self-driving cars. And you know what? I think I'm not even going to talk about that more because like I said, I don't know many practical applications for reinforcement learning. Like I'm trying to think of the broad strokes of what people are really interested in. Like, oops, sorry, I hit my face on my mic. Like I'm trying to think of the broad strokes of what people might be interested in. Okay. So moving on. Then we have the more recent kind of deep learning kind of thing. So you've heard me talk about machine learning, and so this is again where here. Let me share my screen once again. I keep coming back to this GIF today. We would refer to like what is going on here as machine learning. The only thing, the big difference between machine learning and deep learning, the reason that we call it deep is because we'll again at this simple graph here when we're messing with the slope here of this line. That's just a one parameter kind of thing that we're messing around with. But like, as I was saying, when it comes to like these deep learning kind of things, you literally have billions of parameters in here, and so that's why we call them deep, is because we are going deep with how many parameters that we're using, and in particular we're using these mechanisms called neural networks. And so what a neural network is, I actually don't have a diagram up for this neural network. Okay, so this is a very simple like diagram. Well, actually, I'm going to use this one right here just because just to show the complexity of it. Don't worry about what's going on here. The only thing I want to highlight here is just how complex these things are. But basically, like, because of the complexity of these things, now again, they aren't as interpretable, unfortunately, because of the complexity. But on the flip side, we actually can get some really cool results from something like this. So some of the more popular applications of these deep learning neural networks include image classifiers. So if you are trying, if you were trying to figure out, am I looking at a house versus a car? Like, that might not sound like a big deal, but there are lots of companies that are really interested in those sorts of things, especially if you think about, you know, I don't know, the real estate market, for example. Like, let's say you're a realtor and you're taking pictures of a house and stuff. And you want to be able to classify like the different rooms of the house, like, so that way you can like put it in some sort of system or on your website and say, okay, here's the front of the house, here's the back of the house. Having those sorts of image classifiers like that can be really helpful for those sorts of things. So and it's not just limited to images. Like like you can also, like, that's probably the most popular use case of deep learning. But like, we've also had the field of natural language processing. So natural language processing is this whole idea of how do we make sense of human language, like English, for example, because even though, like, if you think about like the semantics of how we say different phrases in English, the syntax is not always the same. So what do I mean by that? So let's use a specific example. So let's say I asked you, what is the capital of Illinois? You may tell me the capital of Illinois is Springfield, or you may tell me the Springfield is the capital of Illinois, or you may say Springfield, or you just may. So all three of those things that I just said, semantically speaking, they all said the same thing, that Springfield is the capital of Illinois. At the same time, all three of those were technically different. They were all syntactically different because I used different words and then different like orderings of the words. And so that's made it very, 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 very difficult for artificial intelligence to kind of make sense of these things. And that's why it's taken so long to get to the point where we are at today with like ChatGPT and whatnot. And so that's that. In the early days of natural language processing, the things that we kind of focused on more so were things like sentiment analysis. So like, is this like a happy kind of, like in the context of movie reviews, for example, like let's say I'm Rotten Tomatoes, like let's say I own the Rotten Tomatoes website. So if you don't know how Rotten Tomatoes works, so like they have the tomato meter, and so with the tomato meter, even though it is like between a 0 and 100%, if you're not aware of this, it's actually not an aggregate score of like what people graded on average. So like let's say we have a ton of reviewers out there and they're giving a score between 0 and 10. It is not an average of like that. So actually, that's how IMDb works, though. If you're curious, though, how Rotten Tomatoes works in particular is that they are just looking at the number of favorable versus unfavorable reviews. So if, like, let's say we have a movie out there like Oppenheimer. I don't know what Oppenheimer got. I'm just using Oppenheimer because I know it just won Best Picture. Oppenheimer, Rotten Tomatoes. Okay. All right. So let me share my screen here again real quick. All right, so this is the Rotten Tomatoes website for Oppenheimer. So you can see that it got a 93% based off of 505 reviews. And we'll just stick with the critic reviews here. That is not saying that out of these 505 reviews, on average, people gave a 9.3 out of 10 or something like that. What it's actually saying is that 93% of the people of this 505 reviews is actually a little bit more they were more favorable toward it or not. So if we actually go and look at these and we start to just scroll through here, so you can see the way that Rotten Tomatoes works is if it was a positive review, then you get the nice looking tomato, or if it was a negative review, then you get like the little splat icon. So if we just scroll through here, you can see like 90% of the time we should see, or 93% of the time we should see more positive reviews. Now we're getting a couple splats in here, but as we keep scrolling, we just keep seeing more and more positive reviews than anything. Okay, so I don't remember where I was going with that. Yeah. So back to natural language processing then with sentiment analysis. You could imagine that in order to I don't know how they do their derivation of this final score here, but in my mind, the simplest way to do that would say, okay, let's just feed in each of these individual reviews and just get a sentiment analysis on this using the natural language processing techniques of AI, and then we aggregate those in the end to say, okay, this was a positive, negative, positive, et cetera, and then have the AI calculate it at the very end. And so that is still another, so most people when you think about natural language processing today, they immediately jump to like a ChatGPT or something like that, or some other generative AI aspect. But in reality, these I guess you'd call them legacy techniques for natural language processing, as I've noted today with the Rotten Tomatoes website, are still very much valid today. I would not recommend ChatGPT necessarily for this kind of thing. I would actually recommend some of these other tactics that we've been using for years. So now let's move into generative AI. So we talked about all these different AI aspects, and I know generative AI is definitely the hot topic. So how should we be thinking about generative AI? That is very much a struggle that I think the entire industry is having right now in terms of what we like to call product market fit. And when I mean product market fit is, I mean that, so again, what happened was, just using, again, my analogy of the drill, is this drill came along and everybody's trying to figure out how to use this drill. Now obviously this was a purpose-built tool. Like, we understand that this tool was specifically built to drill in screws and undrill screws, just like so. With ChatGPT, that's not necessarily the case. So people are still very much trying to feel their way into this space to understand what are the best use cases for it. And some of them are finding really good use cases, and then others are not. So, like, for example, in a case that is not, so if you're familiar with the really popular YouTube reviewer MKBHD, who does like consumer electronic reviews, he got a little bit of heat for giving a negative review to this new AI device called the Humane AI pen. And so if you're not familiar with that, the Humane AI pen, it's this little pen that it's got like a front, and the back it's like a magnetic clasp that you can put on your shirt or like a lapel or whatever, and it doesn't connect to an iPhone or anything, or any sort of smartphone. It connects to the internet directly, and it's interacting. So it's got a little camera on it, and it's got a little microphone on it. So when you press down, you could say, "What's the weather today?" Or, like I said, because it's got a camera on it, it's like, "What am I looking at right now?" And so it'll call back up to the internet, and then it will give a response back. And the reason that it's gotten such poor reviews is because it's just not the product market fit is not there. It is slow. The battery's not great. Nobody wants to wear some sort of like little thing on their thing all the time. I could not wear that into the office. Most people could not wear that into the office. I could not interact with it at a birthday party. I cannot interact with it at church. I cannot interact with it in most places because it is a voice connected kind of thing. So that's where people are still trying to figure that product market fit kind of thing. And so let's talk. So in terms of product market fit, I would say that there are 4 categories in which people are finding product market fit for generative AI in particular. So let's talk about those 4 categories. So the 4 categories are, and these are ones that you can find across the internet. These are actually 4 that I derived myself and that I gave to my own company. But these 4 include content generation. So content generation, when I think about that, is like using something like ChatGPT to say, okay, write me a haiku, or write me a poem, or write me a story in the voice of Jar Jar Binks or something like that. That is content creation. Now that's kind of a more silly aspect, but like a more practical aspect that I know people have been finding a lot of use for in terms of content creation is so there are different products out there, like Hootsuite, for example. That is, so if you don't know what Hootsuite is, it's like the social media manager kind of thing, where it is using generative AI to help like generate new posts that people can use for their own marketing sorts of campaigns. So that is one area where people are getting a lot of value. All right, so that's theme number one. Theme number two is information summarization. So imagine, you know, you want to get the gist of something in a very short amount of time. So like it could be anything. It could be, I don't know, a 20-page legal document. It could be somebody's speech. It could be a book, anything like that. And the nice thing about generative AI is you can take this large amount of text and whatever, and then compress it down into like this very short summary. And so like another cool application of that could be like for call centers, for example. So call centers, you know, if you are recording the transcription of those calls, you can then produce a summary of that. So like let's say I don't know, I'm Apple. I'm the company Apple, and I'm obviously like I love Apple, but a couple months ago I actually unfortunately did have an issue with my personal MacBook where I couldn't get it to connect to one of my monitors, and I kept getting bounced back and forth between different call center employees from Apple, and they did eventually help me resolve it. But if you think about that handoff between call to call to call, if a new person is touching that call every single time, you want to ensure that for a good customer experience, that the new person picking up that call on the Apple side knows what happened before. And so reading the transcript of my conversation from the last person that I talked to isn't really helpful. What is helpful is taking that transcript that we had from that conversation that I had with that first Apple employee, and then passing along to the second Apple employee and say, okay, here's what we talked about. Here, I had this problem. We talked through these things, and here's what the next steps were. That is the kind of value that we can get from an information summarization kind of aspect. And so, and that's just one example. You can have a lot of cool examples like that. Okay. Next on here. So we all right. So content creation, information summarization. Coding assistance. So this is the big third pillar, and this is the one that I like. I know a ton of people are getting a value out of this one. So let's say if you are a software engineer like myself, or no, I'm not a software engineer, I'm a machine learning engineer, but if you write software like I do, and you want to debug it. So for my fellow coders out there, you will know that debugging code can be very challenging. And so the way that we do that typically is we try to look at the documentation first, although unfortunately documentation is not written very well. Again, that's where content creation may be come into helpful. Where with in terms of documentation, you could say, okay, here's all my code. Now AI, look at my code and let's write some documentation on it. And again, you do want to be careful about the different services you're using or not. And let me make a note of that because I want to be. Oh wait, I guess I did make a note of that. We'll get back to that in a little bit. But anyway, when you yeah, so in terms of code, there's all different sorts of things that you can do. So you could even say, like for example, I'm a Python developer, and like let's say I wanted to translate a piece of my Python code into Java code for whatever reason. The generative AI can really be a help for that. Or even if let's say I'm starting from scratch, and like let's say I want to build an API or something like that, I can go into ChatGPT or some GenAI model right now and say, give me an API. I need it to have two endpoints. One's got to be a post endpoint, so on and so forth, and it will produce the code for you. And then the other really cool thing about that is then you can elaborate on that. So like let's say it's gonna be a little bit technical. I'm not gonna try to go too technical here, but in Python, when you build an API, there are two very popular. Well, there are more popular frameworks out there, but there are two very popular frameworks that we use in the machine learning community. One is called Flask, and one is called Fast API. And so let's say that when you write when you ask the model to produce this code for you and it writes it in Flask, I personally like to use. I don't have Flask has actually gotten better over the years, but a couple of years ago I switched over to Fast API because I just like the features of Fast API better. You could tell the AI model, okay, you produce this code here in Flask. I'd rather have it in Fast API. Can you do that for me? And it can. No problem. Or you can just keep elaborating on that. You say, add another endpoint to it. So code generation is an extremely helpful sort of thing. So that's theme number 3. Theme number 4 here is probably the most popular, and I left it for last because I want to talk about this one a little bit more. And I would call this like intelligent search. And so specifically, what people are really interested in is like let's say I build a chatbot, or like let's say let's go back to the Apple example again. Let's say I'm a customer on Apple's website, and I want to know more about a specific product. And I could interact with an intelligent chatbot just like I could with ChatGPT. But the problem with that is using that natively is that the model at the time it was trained may not have like for example, in a couple of weeks Apple is going to be announcing new iPads, for example. So obviously the ChatGPT models, because like we talked about, these models are trained at a snapshot in time. When these new iPads come out, if I go to ChatGPT and I ask what can you tell me about these 2024 iPads, you will get what is referred to as hallucination. And we'll talk a little bit more about hallucinations in a little bit, but basically, in short, it's going to give a fake answer. It's going to sound real, but it's going to be a fake answer. And so the way that you can help ground the information coming from these chatbots is by augmenting the models, the AI model somehow with that knowledge. And I wrote a whole blog post about this like a week ago. I'm not going to go too deep on that because, again, that's starting to get a little too much into the weeds. But basically, the notion here is like, how do you integrate your own company's proprietary information into these AI models? And the reason I'm bringing this up and saving this one for last is because this is a very popular topic, and there's a fundamental misconception around this topic. And that fundamental misconception is so people kind of look at like these GenAI things as almost like like what I refer to as like a spider bot, where you can kind of just drop it in your information repository system, and it would just crawl throughout and figure out all your information. Unfortunately, that is not the case. Regardless if you are working in the AI context or if you're working just in analytics in general or anything, you need to have your data in a place that you can interact with it appropriately. The AI will not be able to figure that out for you, unfortunately. So if you are wanting to like if you're Apple, for example, again, talking about the new iPads, if you want to have a chatbot that can talk at length about any of Apple's products, whether it be an iPhone or the Vision Pro or whatever, Apple needs to get that info. It can't just be like, you can't just drop the AI bot on Apple's website and have it figure it out for you. Apple's going to have to gather that information into something like a vector database or fine tune one of these AI models so you can get that information into there. And so that is a very, and so that is one thing that I'm encouraging people right now who are very interested in this use case kind of idea, and they're not sure where to begin, is like, start gathering your data now. And it doesn't matter, like there is no AI element to here. Start gathering your data now into one place. That way you can interact with it appropriately, and then we'll bring in that AI element to actually enable this piece here. But yeah, it is unfortunate. Like, I really hope in the future someday maybe we can build like a spider bot kind of AI that you could just drop in and figure it out. That's just not the case today, which is disappointing. But if you do have all your data in one place, then you can do some really cool things with it. So like I mentioned the chat bot there, or like if you're a call center employee, for example, and like you get a lot of, like, let's say you're an IT call center and you get a lot of questions from your folks asking different IT questions. If you're a call center employee, you might not know everything to do. So what most companies have is like some sort of knowledge management system. So where you can go out and my screen's not turning on, or I need to reset my password, so I can go and reference these knowledge items. But that takes time. So like if you're a call center employee and you don't know how to do something, now you have to go into the system and you got to figure out, okay, you got to type in and hope that you find the right knowledge item. Whereas if you have all your data in the right place, you can have the AI do that for you. And so what I mean by that is that you can, like, let's say I go back and ask that question. So the particular issue that I had with my Mac again was that it wasn't connecting with one of my displays. You could have an AI system set up where if I'm a customer and I say, hey, something's going goofy with my monitor, then what you could have going on here is this backend system that will automatically go and figure out the right knowledge item to pull from your particular company's information system, and then use that to produce an intelligent response. Now, the one thing I will recommend here, coming back to the whole responsible AI thing, is you still probably do want to have a human in the loop mechanism there. Unfortunately, so let's come back to this idea of hallucinations. I glossed over it really quickly. When it comes to these generative AI models, hallucinations are, because what the way that these models kind of work is that when they are trained on the data, it is basically trying to predict the next word that it sees. So the example that I always like to use is let's fill in the blank for this this word at the end of the sentence. Oh my gosh, what I'm blanking here. Every morning, comma, I like to drink blank. How do you fill in that blank? So the way that the AI model knows how to fill in the blank is, so when I mean that these large language models have been trained on literally the entire internet, they've been trained on like terabytes of data, just looking at like what people have said over time. So naturally, then most people are going to fill in that blank as in the morning I like to drink coffee, or I like to drink milk or water, or something in the neighborhood of a breakfast beverage. But it is all probability. And so it will always give a response, but that may not necessarily be the correct response. And so let's say if I went to ChatGPT right now and I said, my name is David Hundley, in the morning I like to drink blank. Well, it's not going to know what I like to drink, because I don't think I've typed out on the internet somewhere that I specifically like to drink iced coffee. And so the way that you would kind of so it would give a hallucination there. So it would say, my name is David Hundley, in the morning I like to drink, and it's going to fill in whatever the heck it feels like, or not whatever it feels like. It's going to fill in the most probabilistic value. And so in that case, it won't be associated to me. It could say coffee, or it could say tea, or whatever, but those aren't necessarily correct. So if I wanted to actually tamp down those hallucinations, the way you do that, again, I wrote a whole blog post about this, is that you want to ground that model somehow with your own information. That could be with this idea that we call retrieval augmented generation, or RAG for short, but it's basically augmenting the knowledge of the model somehow. And that could just be simply passing in extra text. So if I were to type into ChatGPT right now, my name is David Hundley, I like to drink iced coffee every morning, fill in the blank for this next sentence. And then the next sentence was, in the morning I like to drink blank. Well, now because I gave it that extra context of saying I like to drink iced coffee, now the probability of it filling in that blank correctly is extremely high. And so that's how you tamp down hallucinations like that. But those are the sorts of things that you want to be careful about, because that's what's gotten people burned in the industry. So like, for example, there was a case like last year where I don't remember the details on it, but there was like a lawyer who used ChatGPT to produce some sort of legal precedent, and it cited something, and that the citation ended up being a hallucination. It ended up being something that did not exist at all. And so that lawyer got in trouble, and I don't remember what happened. He may have gotten disbarred, or like, what's the other one? There was an airline. I think it was an airline. There was some sort of company that they were offering, like they were using like a customer service chatbot that the chatbot was hallucinating and saying, okay, yeah, we'll refund you on something. I think this was an airline, maybe Air Canada or something like that. I don't remember. But basically, they got in trouble, and they were basically said, you know what? Even though your chatbot hallucinated and it gave a wrong response, sorry, you're on the hook. And company, you have to honor whatever that just said. And so again, coming back to that whole responsible AI thing, I would recommend having a human validation mechanism every time. That way you can make sure that you are being careful with those hallucinations. And this is considering, like, I think whatever company this used, they were using one of those retrieval augmented generation techniques that I was talking about, where they would actually go and look at the company's policies and stuff, and it still hallucinated. And I think part of that is that these models are getting better and better over time. So even though it's kind of crazy to think about, like when ChatGPT originally came out in November of 2022, so the model behind that is actually, the formal name of that is GPT 3.5 Turbo. GPT 3.5 Turbo is actually not a very good model anymore. Like, it's not considered that performant. If you go and look at the leaderboards, GPT 3.5 is nowhere up on the leaderboards. Up on the leaderboards is these newer models, like the newest version of GPT-4, or Llama 3 70B, or Claude 3 Opus. These newer models. So as like I keep saying, the technology is going to just keep getting better and better from here. And there are other concerns to be mindful of when it comes to generative AI, because the one thing that kind of irritates me about the AI community, specifically over on Twitter, is it hypes up too much open source models, I think. And what I mean by that, apparently me giving the thumbs up, I forgot about that. The Macs have that new feature. There, right? That thumbs up thing, that's computer vision in action. It saw my thumbs up and it gave whatever. Anyway, I totally lost my train of thought though there. But I hope you can kind of get a sense of, here are the things that we need to consider. But it all goes back to this idea again. I'll even show my notes here. Let me pull up my notes here. And so, all right, so these are the notes I've been operating on throughout this whole conversation here. Domain knowledge is important. You can see I put all caps, lots of exclamation points. Domain knowledge is important because your domain knowledge as business leaders is really going to impact how we use AI. And again, AI is a tool. AI is not something that you say, okay, what are we going to do next quarter? Well, we're going to go incorporate GenAI. No. We need to figure out what the actual business problem is that we're trying to solve for here. And the whole reason I went through the whole, talking about all these different AI things is by having a base level education of what these different types of AI are, I hope you can kind of make that connection for your own business processes. So like when I talked about the unsupervised learning with the customer segmentation through the Starbucks data that I was talking about, I hope that you marketers out there, if we have any marketers watching, get an idea of how we might use unsupervised learning for marketing, or our time series analysis kind of stuff out there. If you're a grocery store owner out there, I hope you get the sense of, okay, here's how we can use AI for predicting the sorts of things that I should keep on the shelves in the next couple months. And I know for a fact, because I took a time series course last year from a guy that he used to work at Kroger. It's these grocery stores do exactly what I'm talking about here. Or with generative AI, how we talked about how it can help out with call center sorts of activities in different sorts of ways and making the customer experience better. My goal here with this whole stream is let's help you to build this frame of reference for AI and how to think about AI and how to apply it to your own business practices. And again, it doesn't matter if you are in a Fortune 500 company or if you're just in a mom and pop shop. These principles are all remain the same. All right. So I guess the last section here, we touched on this a little bit, and that is what AI can't do. So one thing I mentioned already, it can't crawl your data, unfortunately. So again, coming back to that whole spider bot notion of just dropping the AI and having it figure out your systems, unfortunately, that is not the case. But the other point I want to highlight on here is that AI can't read your mind. And that sounds kind of, silly, I guess, but it's really important to remember because I think a lot of people, especially with this generative AI revolution, have this fear of, well, especially with software engineers, is the AI going to take over my job? And I don't, I mean, it might decrease the need for software engineers or whatnot, but here's the problem. If you think about, especially if you work in a large organization, how do you know what to build? The AI, and that's the thing is because these AI models, even though we call it artificial intelligence, these AI models, especially the chat GPTs or these other generative AI models out there, there's actually no, it's ironic that we call it artificial intelligence because there's actually no intelligence going on there. It's just very, very fancy math, as I like to call it, and just statistical probability. And so what I mean by there's no intelligence in there is that when it comes to the business aspect, the AI can't talk to your CEO. They can't tease out what's in your CEO's mind or what's in your executive's mind, trying to figure out those things, or trying to figure out the whole context of your whole organization. Can ChatGPT produce code for a beautiful looking website? Of course it can. But what if you want to adhere to a specific brand ideology and saying, you know what, we want to make sure that we are always using these specific colors or this specific format or whatever. Those are the sorts of things that AI cannot solve today. And I don't know if they'll ever be able to solve. And it goes back to that whole idea, like I said, AI can't read your mind, and it can't read your boss's mind, and it can't read your customers' mind. The human is still very, very important in those regards. And I keep coming back to this whole idea again. Domain knowledge is so important, especially in the AI space, because your domain knowledge of understanding these sorts of things helps to understand, okay, when I think about an AI strategy, a collective AI strategy, I'm talking about the full stack. I'm not talking about just Gen AI. I mentioned the call center stuff. The call center stuff, I can actually think of ways in which we could use all supervised learning, unsupervised learning, time series analysis, deep learning, generative AI, all 5 of those in different ways to build this holistic AI sort of strategy here. And so, it is glamorous right now to look at GenAI, and GenAI is extremely cool, to be clear. But it is just, like I said, it's another tool in the toolbox, and you may use it more often. Yeah, I use my drill all the time here. I don't use my vice grips as much. So I might not use unsupervised learning as much. But when I need the vice grips, this drill is not good. Like this drill, when I strip my screw, I'm screwed. Well, pun not intended there. So I need my vice grips to get that screw out. And so the same is true for AI. AI, you got your full tools, your full tool set, and how to think about everything. So we're gonna go ahead and call it there. So I don't really have it like that. That's a general primer to AI. So I hope you all have a good sense of how to think about AI for your own business practices. And we all have our own responsibility, and it doesn't matter. Like I said, so if I work in a very large company. It doesn't matter if you work in the marketing department. Doesn't matter if you work in the legal department. Doesn't matter if you work in the IT department. We all have something that we could probably apply AI towards in some sort of business capacity. And your knowledge as business leaders is extremely vital for helping with that. So we're going to go ahead and call it there. I don't see any questions or anything. So I hope you all enjoyed this one. Like I said, we will get back to the MLX Gradio project here in the next week or so. And if you ever have any questions about what we talked about here, feel free to DM me on X or on LinkedIn. I'm happy to answer any questions. Again, I won't take any questions about State Farm. That's just, this is not the right context for that. But and again, I love my company. I love working for them. I love my job. I think my job is so great. It's like this week. Part of the reason that I didn't get to the code is we had my leadership in town. We, seeing familiar faces and meeting new ones. It was a fantastic week. And I love working in the space that I do. I love working with the people that I do. It's just unfortunate that I didn't have the time to do the MLX Gradio stuff. But yeah, so at least we got to have this chat today. So thank you all for watching. Hope you all have a great weekend, and I will see you in the next one. Thank you.